My name is S. Gurshankar. Today our topic is AVL trees. An AVL tree is a self-balancing binary search tree in which the heights of the left and right subtrees of any node is at most 1. This is achieved by performing rotations on the tree when the balance factor of a node becomes greater than 1 or less than -1. The AVL tree is named after its inventors Georgy Adelson Welsky and Evgeny Landis, who published it in their 1962 paper, An Algorithm for Organization of Information. AVL trees are often used in applications where the data is constantly changing, and maintaining a balanced tree is most for efficient search, insert, and delete operations. In the following figure, we can observe that it is a AVL tree because the heights of the subtrees, left and right subtrees, is always between -1 to 1. To balance an AVL tree, we perform the operations like left rotation and right rotation. In the following figure, the balance factor of A is 2. That is, it has the height of two subtrees. Now we perform left rotation to make the balance factor of A, B, C to 0. Here is the code to perform left rotation. In the following slide, we perform right rotation. Here, the balancing factor of A is 2 because the left subtree has height 2 and the right subtree has 0. Now, we perform right rotation to make the balancing factors for A and B and C to 0. Here is the code to perform right rotation operation. In this slide, there is a left-right rotation process. Here now, we first perform left rotation for AB, AB3, and then again we perform the right rotation for BC, which makes the balancing factors for A and B and C is 0. In this way, we balance our AVL search tree. Similarly, we perform right-left rotation process also. First, we apply right rotation for B and C tree, and then again we perform left rotation for A and B, which makes the balancing factors as in the picture. In this way, we perform right-left rotation process. The following is the code to perform different operations on AVL search tree. The different operations are insertion, deletion, and the traversal. The traversal can be performed in 3 ways: pre-order, in-order, and post-order, as like binary search tree. We can see that there are more applications of AVL tree. These are used indexed huge records in database and also to efficiently search in that. For all types of memory locations, including sets and dictionaries, AVL trees are used. Database applications where insertions and deletions are less common, but frequent data lookups are necessary. Software that need optimized search, it is applied in corporate areas and storyline games. You can see that AVL tree has advantages and as well as disadvantages. The advantages are AVL tree is a self-balance and it is not skewed. Better searching time complexity compared to other trees like binary tree. Height can no exceed log n. Now the disadvantages are it is difficult to implement. It has high constant factors for some of the operations.